Ever wonder how you're supposed to handle huge files, like photos and videos, in a system design interview? Well, you're in exactly the right place. Today, we're going to demystify object storage and give you a clear playbook to absolutely ace that part of your interview.
Okay, let's just dive right in. Here's our roadmap for today. We're going to start with the why, the big problem that object storage was created to solve. Then we'll get into how it actually works, what you absolutely need to say in an interview, and finally, we'll cover the big names you should know.
So, first things first. We have to understand why we can't just cram everything into a standard database. I mean, it seems like the easy way out, but it turns out there's a really good reason your database absolutely chokes on big files.
And this is really the fundamental question, isn't it? We're talking about things like images, videos, big log files. In the tech world, we call these things binary large objects, or just blobs for short. So why can't our trusty SQL database handle them?
Well, the absolute key thing to get is that these are two totally different tools for two very different jobs. A normal database, it's a rock star with small, structured data that changes all the time, like a user profile or the text of a post. It's built for complex queries. But object storage, it's designed for massive, static files. Files that you write once and then read over and over. And if you use the wrong tool, well, you're in for a world of pain. Let's make this super real for a second. Imagine you're building a social media app. And you think, hey, for convenience, let's just store a user's 4 MB profile picture right there in the user table, next to their username. Seems simple, right? But what's happening under the hood is a complete mess. And here is that mess. See, a database like Postgres breaks everything down into these little 8 KB chunks called pages. Your one single 4 MB photo, it gets shattered into a staggering 500 of these pages. That's a ridiculous amount of overhead for just one file. And this is where you start to feel the real pain. Suddenly, a simple query like show me the top 50 users becomes painfully slow because the database is trying to wade through all this image data. If you have replica databases for backup, you're now copying that entire 4 MB file every time it's written, causing lag. And the worst part? The backup nightmare. If your database goes down, what should be a quick, minutes-long restore can turn into a multi-hour ordeal. Your whole service is just down. So yeah, the bottom line is simple. Traditional databases were just not built for blobs. They choke on them. It's the wrong tool for the job, and it will hurt your performance, your stability, and your wallet. This is the exact problem that needed a better solution.
All right, so enough about the problem. Let's talk about that better solution. We're going to pop the hood on object storage and see what makes it so simple, cheap, and durable.
The architecture is actually beautiful in its simplicity. Instead of one big, complex system, it's split in two. You've got this lightweight metadata service that's basically just a giant address book. Your app asks it, hey, where can I find file.jpg? The service looks it up and says, oh, that's over on storage node A. Then, your app goes directly to that simple, cheap storage server and gets the file. That's it. It's an incredibly scalable two-step lookup. So, what makes this simple design so powerful? Well, it really just boils down to 3 core principles. And once you get these, you'll see why object storage works so incredibly well. Okay, first, a flat namespace. Forget about folders inside of folders. Every single file just gets a unique ID. It's like a giant code check system. You give them your ticket, they find your code instantly. It's super fast. Second, immutable rights. You can't edit a file, you just upload a new version. This gets rid of so much complexity. And third, radical redundancy. Every single file gets copied over and over and over again across different machines and different locations. And that redundancy is what gets you to this mind-blowing number, 11 nines of durability. That's an industry term, and it basically means that losing a file is a statistical impossibility. To put it in perspective, if you stored 10,000 files, you could expect to lose just one of them, maybe once every 10 million years. The system is designed so that even if an entire data center goes offline, your data is still safe somewhere else. Okay, so now you get the why and you get the how. So let's wrap all this knowledge up into the 3 essential points you need to drop in your system design interview to really show you know your stuff. This right here, this is your interview playbook. You need to talk about these 3 implementation details. If you can confidently explain these, you're not just saying, oh, I'll use object storage. You're showing that you actually know how to use it in a real system. So let's break them down. Number 1, and this is the most important, you must separate your files and your metadata. The small stuff that you need to search and query, like the post ID, the user ID, the caption, that stays in your fast, traditional database. The giant file itself, it goes into object storage, and you just keep a simple pointer, a URL, to it in your database.
Number 2 is explaining how you'll handle the actual uploads and downloads. The rookie mistake is to route the file through your own application servers. The pro move is to use pre-signed URLs. Your server generates a special, temporary, secure link from the object storage service. You hand that link to the client, and the client communicates directly with the storage. This saves all of your server's bandwidth and compute power.
And third, for the bonus points, for the really huge files, you bring up multi-part uploads. This shows you're thinking about real-world problems like flaky internet connections. The client, your web browser or mobile app, slices the big file into smaller chunks, uploads them all independently, and then the object storage service puts it all back together. It's just a way more reliable system.
Finally, let's ground all this theory in the real world. What are the actual names of the services you'd be using?
In the cloud, there are really 3 big players that dominate. You've got Amazon S3, Google Cloud Storage, and Microsoft Azure Blob Storage. And you know what? They all work on the exact same core principles we've just been talking about. Now here is a massive pro tip for your interview. If you're ever in doubt, if your mind goes blank, just say Amazon S3. It was the first one, it's the most popular by far, and it's basically the industry standard. Your interviewer will 100% know what you mean.
So, there you have it. You've just solved the massive problem of storing and serving huge files. You've offloaded all that heavy lifting to a specialized service. But in system design, as soon as you solve one bottleneck, another one appears. So that leaves us with a final question to think about. What's the next part of your system that's going to break?